So, welcome back to the night class. And we're going to do lesson 5.1. Okay? Lesson 5.1, this chapter we're going to be talking about graphing absolute value functions. This first little slide here is just basically talking about the features of an absolute value function. I want you to know if it's absolute value, everybody watch this. Absolute value. Those are going to be what your graphs look like. It will either be an A or a V. Okay? So if when you graph your absolute value, if you don't have an A or a V, you either have done it wrong or you need more points. Okay? And what do I mean by that? Well, sometimes you can pick, now if you do it the way I show you, you won't have this problem, but sometimes you can pick points that are only on one side and it looks like a what? It looks like just a line. Okay? So you don't want to do that. You want to make sure you have points on both sides. This is called the parent graph. It's just the absolute value of x. All right? And so what you're going to do, your first point should always be what makes the absolute value 0. Now notice, I didn't say what makes x 0. What makes the absolute value 0? Does that make sense? Okay? So in this case, what makes the absolute value 0? 0. So this right here, that is your vertex. Okay? You get the y like you always get the y, you plug in the x. 0, absolute value 0 is 0. Okay? And then what you're going to do, since it is an A or a V, every point has a little buddy on the other side with it that it's symmetric to. Okay? So the way to get those points is you always go an equal direction on either side of your vertex. So your vertex is your first x. Okay? And then if you want to go 1 to the right, make sure you pick a number that's also 1 to the left. Okay? If you want to go 2 to the right, that's fine. Just make sure you pick a number that's 2 to the left of your vertex. All right? And if you do that, you'll always see that the y's will stay the same. So what do I mean by that? What's 1 to the left of 0? -1. Well, if you plug in -1, what is the absolute value of -1? 1. Now, many people should have started with this. Absolute value is not just, it's the positive of any number. Yes, it is. That's what it is. But what is it actually? When I say absolute value of a number, what am I talking about? Yes, ma'am. Oh, that's awesome. It's how far away the number is away from 0. You got me? Think about real life. If you're driving to Pascagoula and somebody's not from around here and they say, hey, how far is it to Pascagoula? You don't say it's -20 miles to Pascagoula. Okay? Because, well, we're going down, right? Down's negative, but we don't say negative. When you're talking about distance, distance is always referred to positive, as a positive number. Now, you might say 20 miles south, or you might say 20 miles west, but you don't ever say negative. Is that making sense? Okay? So, distance is always positive, so that's why absolute values are always positive, because the absolute value is literally the distance a number is away from 0. How far is -40 away from 0? It's 40. If you were on -40 and you started walking to 0, it's going to take you 40 steps, or 40 paces, or 40 miles, or however long it is. Is that making sense? Okay? All right. So, you're just picking points the same distance away from your vertex. So if I go -1, I'm also going to do +1. They both give me 1 when I plug them in. That makes sense? When I plug in -2 and +2, they both give me +2 when I plug them in. Okay? And then you just graph your points. Boom, boom. They're everywhere. Okay? And you draw your V. All right? Like I said, where it changes direction, what is this point called? The vertex. Okay? It is the vertex, the axis that cuts it in half. And understand, the axis of symmetry doesn't have to be the x-axis or the y-axis. It can be any line that cuts it in half, okay? It just so happens on this particular one, what is the axis of symmetry? What's cutting that in half? The y-axis, okay? That's also referred to as x equals 0, okay? So, very important here. The x part of your vertex is always your axis of symmetry. I'll say that one more time. the x part of your vertex is always the axis of symmetry. So if I tell you your vertex is 4, -6, what's the axis of symmetry? X equals 4. Some of you said 4. I wanted you to because it's wrong. Okay, I wanted you to hear why it's wrong. All right? The axis of symmetry is a what? It is a line. Okay? Therefore, you can't just say it's 4. You have to say it as an equation because 4 doesn't tell me anything. X equals 4 means every point on this line, X is 4. Okay? In our particular one, every point X has to be what? 0. So if it ever asks you what's the axis, you have to say X equals whatever the axis is. Does everybody understand that? Because it is a line that you're talking about. Everybody good? Okay? All right. Moving on. Let's try one. Now, we've already graphed this in the first part. All right? It says, what is the domain and range? Well, I'm going to scroll back up here, and let's look at our graph here. What's the domain and range? Domain, remember, is all the what? What can X be? What can X be? Anything. It goes forever to the right. It goes forever to the left. So X is all what? All real numbers. Your domain is all real numbers. But what about your range? Does it go down forever? No. Does it go up forever? Yes. Where does it go down to? What's the lowest it can be? 0. So, what's your range? Correct. Domain would be all real numbers. Okay? Your range, y has to be greater than, can it equal 0? No. It can. Okay? Not every time, but very similar to that. Now, I'm glad you asked that. She asked a great question. She said, will it be like that every time? The domain will be all real numbers every time. If you're talking about what type? Absolute values. Okay? Yes, your domain, but your range can change. Because remember, this V, it can move, right? It can move up, it can move down, it can move right, it can move left. Okay? So, for the range, you're really not worried about right and left. You're just worried about how far up or how far down. Okay? All right? Transform, here we go. We've already talked about transformations, so this should be easy. Okay? How do the domain and range of g of x equals 2 times the absolute value of x compare with the domain and range of f of x equals absolute value of x? So, what did the 2, where is it?
On the outside.
It's on the outside, so what's that going to do to my graph? Vertical stretch. It's vertical because it's where? Outside, and it's stretching because it's bigger than 1. Okay? So, what does stretching it do to the domain? If I'm stretching it vertically,
It shouldn't change because it's going to be all.
doesn't change at all. I just told Desi the domain will always be what? All real numbers. Okay, so you're not changing that. The only thing you're changing, sometimes maybe, is the range. But do I even change the range? If I'm stretching it? Did I move it up? Or did I just stretch it? I just stretched it. So the range doesn't change either. The only thing that changes is the graphs. Okay? The graph is skinnier. So that's why it says the domain is still all real numbers. The range, it says, is still y is greater than or equal to 0. Okay? So multiplying it by 2 didn't change the domain and range. Okay? How could I have changed the domain and range? What would I have to do to change the... we've already established we're not changing the domain, but what would I have to do to change the range?
Slide it.
Slide it. Translate it.
Translate.
Translate it, and I'd have to translate it where? Not up, left or right. Up or down. Okay? So I could move this like there. All right? Now, what's my range?
Y is greater than or equal to 2.
Because it's now moved what? Up to 2. It can't go past 2. Okay? What else could change the range? What if, there you go. She said flipping it upside down, which is called what? Reflection. So if there was a negative out front there, well now, rather than being, let's just say it's this one, so it looks like this. So now rather than being greater than or equal to 0, it would be, hey, less than or equal to 0. Does that make sense? That's pretty much the only thing that changes, okay? All right. Oh, look. We just talked about that. What happens to it? The range is now flipped. So it's reflected, so now it's less than or equal to 0. Does that make sense? Okay. Again, does the domain change? Does the domain change? No. Okay. All right. We'll skip that.
So the domain never changes?
Not for absolute value functions. Okay? Not as long as the x is in the absolute value. All right? Jay rides in a boat. He says he rides from his home to his friend's home in a neighboring state. The graph of function d of t equals 30 times the absolute value d minus 1.5. Shows the distance of the boat in miles from the state line at t hours. Assume the graph shows Jay's entire trip. How far does Jay travel to visit his friend? So here's the graph. Okay? This looks really, really complicated, but it's not. Okay? Focus on the graph here. Notice what you're talking about. What's my x down here? It's what? Time. This is distance. Distance from what?
Distance from state line.
Distance from the state line. Okay? So, he starts here. How far is he from the state line to begin with? 50 miles. Or actually, is that, nope, not 50. That's what? 45. Okay, he's 45 miles. Then he goes, drives where? When he gets to here, where is he? He's at the state line. So he's driven how far? 45, because he went from 45 to 0. And then to get to his friend's house, he goes, how far? Another 45. So 45 plus 45 is 90. He drove 90 miles. Okay, is that making sense? All right.
Why is time on the bottom?
Why did he drive
Side?
It just, this particular problem, because your time doesn't ever stop like we talked about. Okay, it's always going to be your independent variable. Your distance depends on how long you've driven. You got me? Okay?
Why did he drive straight?
Oh, I don't know.
Because he's Jay and he wanted to say.
All right, here. They're asking you. Y'all listen. Stay with me real quick. We're almost done. What is the domain for this particular problem? It's not all real numbers. I just lied to you. Why is it not all real numbers now? Because it's what? What kind of problem is it?
Real
It's
life.
real life, okay? You don't have negatives in real life, really. All right? So, here's my domain down here, right? So it starts where? At 0, and then we end it at what? How many hours? 3 hours. So from 0, less than or equal to t, less than or equal to 3. That's your domain. What's your range? Okay, you said 45 to 0, but you really mean what? Always start at the bottom. 0 to what? 45. Because listen, this graph is not, you can get the total distance, but the distance at any point is telling you how far you are away from the state line. You got me? So, it is from 0, less than or equal to distance of time, less than or equal to 45. That would be your range. Okay? All right. Almost. Hold on. We do not have homework. Study for your test. All right. Last thing. Y'all listen. Stay with me real quick. Okay. Here, it says, what is the rate of change, a.k.a. what? Slope, over the interval 2, less than or equal to t, less than or equal to 2.5. So, are they talking about the entire thing? No, they're just talking about from here to there. Okay? what is the rate of change from there to there? You just find the slope of that little section right there. Okay?
30.
So, what is the slope? Let's see here. We're rising.
So it's 15.
We're rising. We go from what? 15 to 30. So that's up. How far?
15.
15 over
Oh, wait.
half of. Wait, that's 3.5. No, that's 2.5. So over
So it's actually
0.5 of an hour.
So your
Is that
slope
right?
is 30.
So if you simplified that, your slope would be 30 miles per what?
Hour.
Per hour. Any questions? All right. Y'all make sure you study for your test. And as always, stay above the line.